Okay, looking at problem number 1, we're going to ask ourselves, because we're trying to classify this. Is it going to be a parallelogram? Is it going to be a trapezoid? Or is it going to be a kite? Well, looking at these options, we know it's a parallelogram right away. Opposite sides have the same slope, so we know they're parallel. Even this counts. Undefined, undefined. That's parallel. So we know it's a parallelogram, but so, you know, we can eliminate trapezoid. It's not a trapezoid, it's not a kite. But it should probably jump out at you right away that this is in fact a rhombus of some kind, as opposed to merely a rectangle. Well, I guess it could be both. But we're going to take the rhombus track. We see that all 4 of these sides are congruent. That is the definition of a rhombus. So here we are looking at rhombus. But then the next question is it a square? And that's where I lose a lot of kids. Sometimes you guys will just write down rhombus and call it a day. But we have to go further than that. The thing is, this is going to turn out to be a square. Okay, not just a rhombus. And it's because, you know, even when you look at these, normally we're looking for, are these slopes opposite sign and reciprocal? Well, when you're dealing with 0, there's really no reciprocal. But remember this, if you're talking about a slope of 0, that is a horizontal line. If you're talking about a slope that's undefined, that is a vertical line. Guess what? If you have a horizontal line and a vertical line, they are perpendicular. So please understand, when you see a 0 slope and an undefined slope consecutive like that, you are talking about perpendicular lines. So since it's perpendicular, 90 degrees, that makes this a square, not just a rhombus. So you would write, it is a square because it has 4 congruent sides and 4 right angles. Do not leave out any part of that. Because it is at the bottom of the list, once we get down here to square, because that's at the bottom of the list, you do not have to say what it is not. There's nothing more specific than square that you have to worry about. Alright, let's move on to number 2. If DRKM is a rhombus, which statement is not always true? So it mentions rhombus, so let's go ahead and draw ourselves a rhombus. Okay, fine. So here's a rhombus. DRKM, let's label that. Okay, so DRKM. Let's see, if dr equals radical 3, so that would be like that, then kr equals radical 3. Kr is right here. Is that always true? Yeah, that's always true. This is a rhombus. If it's a rhombus, all 4 sides are congruent. If this is radical 3, then they're all radical 3. So that is always true. We're looking for one that is not always true. So A cannot be the answer. Okay, what about part B? The slope of dk is 3. If the slope of dk is 3. Okay, so this is dk, like this. I'll put an arrow to remind us that we're talking about the slope. So let's say if that slope is 3, then the slope of Rm is -1/3. Okay, Rm would go like this. Here's Rm. Okay, so we're talking about the diagonals, and see, we're saying -1/3. So look, if we have a slope of 3 and then a slope of -1/3, those are perpendicular because they're opposite and reciprocal. So we are really asking, are the diagonals of a rhombus always perpendicular? Alright, let's look back at our properties of a rhombus. Okay, as you recall, the definition of a rhombus right there is 4 congruent sides. But if we scroll down, Okay, the first property of a rhombus is the diagonals are perpendicular. We also have other properties, but one property of a rhombus is the diagonals are perpendicular. Okay, that means if you have if one slope is 3, the other one will always be negative 1/3, because that's what happens when lines are perpendicular. So this will always be true. And we're looking for one that is not always true. So B cannot be the answer. Okay, if the slope of dr is 1/2. Okay, so here's the slope of dr, and say that's 1/2. Will the slope of km always be 1/2? Like this. Well, yeah, that's always going to be true. A rhombus is a special kind of parallelogram. So opposite sides of a parallelogram will always be parallel. That goes for a rhombus as well as all the other parallelograms. So if this side is 1/2 slope, the opposite side will always be 1/2 slope as well. So C is again always true. So that means C is not the answer. That means D must be the answer. But let's go ahead and look at it and see what's up. If the slope of dr is 1/2, okay, so again dr has slope 1/2, then the slope of rk is -2. Okay, so here's rk, and will that slope always be -2? See how these are opposite sign reciprocals? Well, that would mean that this is a 90-degree angle right here. If this is a rhombus, is this always going to be 90 degrees? No. That's only if it's a square. And it's not necessarily a square, it's just a rhombus. So this will not always be true because it's not a square. So D is the answer because that's the one that's not always true. Okay? You have to memorize the formula for the area of a trapezoid. So practice this formula. You need to walk in knowing the formula by heart. I'm going to add it to the flashcards. I'll make a set of flashcards with all the formulas on it. But plan on knowing this by heart. Anyway, its the area of a trapezoid is 1/2 base 1 plus base 2 times height. So let's just do that. So this area is 1/2. Okay, now I need base 1 plus base 2. So, okay, that's 30 and 10. Times height, which is 24. Alright, just put that in your calculator. Well, that is 480. Okay, so that's the area of that trapezoid. Now the perimeter. We have to do a little bit more work to find the perimeter. Of course, the perimeter is the sum of all the sides around the outside. Alright, we know two sides, so we need to figure out the legs. This, I forgot to tell you, but this is an isosceles trapezoid. Okay? This is isosceles, so ST and AR will be the same. Now with that in mind, we need to be ready to do the Pythagorean theorem. So it will help us if we make another right triangle over here like this. Now with that in mind, you see this 10 right here? Can we all agree that this is going to be 10 right here as well? So that red piece I just drew was 10. If I take 10 away from this 30, that leaves 20. Okay, now that 20 is to be shared equally between this piece and this piece. So what do we have? Okay, so that's 10 and 10. Alright, and that makes sense because it's going to be 30. If this is 10, then 10 plus 10 altogether, that makes 30. So that makes sense. But look, we need to know what the legs are, like ST. So the first thing I'm going to do is the Pythagorean Theorem. So if I do, maybe I'll do this to the side. Okay, so here would be my Pythagorean Theorem. A squared plus B squared equals C squared. Okay, if I take the square root of both sides, I get 26. Alright, that means the legs are 26. So this is 26 and this is 26. Okay, so now I'm all set to do the perimeter. So my perimeter is going to be 30 plus 10, the two bases, plus 26 plus 26, the two legs. Add that all up and that's going to be my perimeter. So that is 92. Okay, number 5. Area of a parallelogram. Well, this is the easiest one of all. Area is just base times height. So that's just going to be 20 times 10. So that's just going to be 200. And that's all. Okay, now here's another formula that you need to know by heart. The formula for the area of a kite or a rhombus. 1/2 diagonal times diagonal. This will not be given to you. I will put it on the flashcards I'm going to make, Quizlet, but you need to know these by heart. Okay, I think it will help if you draw yourself a picture. So we're talking rhombus, so let's get a picture of a rhombus going. Okay, so here's my rhombus. Okay, B, H, and M. So here we go, B, H, N, M. Alright, BH is 7, so this is 7. And M is 7, so this is 7. Look, this is a rhombus, so we know that all of these are 7. Okay, so fine. But what else you got? BN is 5. What's that? BN, that is a diagonal, correct? Okay, so BN is one of my diagonals, and that is 5. Okay, and then what else we have? HM is 6. Alright, HM is the other diagonal. Okay, so HM here is 6. Okay, and this guy right here is the one that was 5. Maybe I'll just move it up. Okay, the point is that BN and HM are the diagonals. That's the main thing. So if you understand that, this is a diagonal, we'll call that diagonal 1, and this is a diagonal. That's diagonal 2. So if you understand that, then we can just use the formula. The area of a rhombus is 1/2 diagonal times diagonal. So that's going to be 1/2 5 times 6. Okay, and we don't need a calculator for this. This is 5 times 6 is 30. And half of 30 is 15. Okay, so the area of this rhombus is 15. We don't need a calculator for the perimeter either. The perimeter is the total of all these lengths around the outside. 7 times 7. I mean 4 times 7. Okay, 4 sevens is 28. So that's going to be the perimeter. Okay, let's look at number 7. A square is a special kind of rhombus and a special kind of rectangle. SQRE is a square. Okay, again, we should probably draw it. Okay, so here is a square. Okay, SQRE. SQRE, okay? SQ is 12. So that's 12. QR is 12. Okay, it's a square. We already knew that. RE, yeah, all the sides are 12. We get it. Okay, but they're also giving us the diagonals. Okay, please understand that QE is a diagonal. Okay, this is QE. And I'm just going to color match it. Okay, QE is this diagonal. It's 12 radical 2. And SR. SR is also a diagonal. Alright, and I'm just going to circle it in green. So these two are the diagonals. Keep that in mind. Now, let's calculate the area using the formula for the area of a parallelogram. Okay, of course, we know that a square is a special parallelogram. So there's no reason why I shouldn't be able to use the formula for the area of a parallelogram, which is base times height. That should work for a square because it is a parallelogram. Well, look, the base and the height are, the base is 12 and the height is 12. Okay, so looking at it that way, base times height, that's just going to give me 12 times 12, which is 144. On the other hand, calculate the area of the square using the formula for the area of a rhombus. Well, look, a square is a rhombus. Okay, it's a rhombus and a parallelogram. So a square is a rhombus, so I should be able to use the rhombus formula if I wanted to find the area. Okay, we just learned that the area of a rhombus is 1/2 diagonal times diagonal. So we should be able to do 1/2 diagonal times diagonal to find the area. So let's do that. Okay, area equals 1/2 diagonal 1 times diagonal 2. So that's going to give me 1/2. Now remember, the red and green here are my two diagonals. So that's going to be 12 radical 2 times 12 radical 2. Okay, if you put that in your calculator, guess what you get? 144. We better get the same answer because it's the same square. It better have the same area no matter how we calculate it. But there's one more way to calculate the area of a square. When we did base times height, and we did 12 times 12. For a square, will these ever be different? No, they're always going to be the same thing. So we didn't really need to call one of them base and one of them height. We could have just called them both a side. And I'll just use S to represent a side. So whatever is the length of a side of a square, we'll wind up doing side times side. You know, base times height is just side times side, or side squared. This would be a little formula for the area of a square. So that would just give us 12 squared, which again is 144. Okay, so that's 3 different ways we could think about calculating the area of a square. Okay, alright, last problem. kite FOAD has these vertices. Okay, -2, 1. Okay, that's F. 10, 7. All right, that's O. 4, -5. That's A. And -2, -5. All right, and that's D. Okay, so here's my kite. Now, we are supposed to find the area of this kite. Do we know a formula for the area of a kite? Well, yes, we do know the formula for area of a kite. Area of a kite is the same as the area of a rhombus, 1/2 diagonal times diagonal. So we need to know what the lengths of these diagonals are. So we need to know the length of DO, for example. Okay, that's one of the diagonals. Let's go ahead and find that real quick right now. So DO, why did I put a Q? Okay, there's that Dairy Queen again. DO, if we want to find that length, we will just simply use the distance formula. Okay, using points D and points O. So x minus x, so 10 plus 2 squared. And then y minus y, so 7 plus 5 squared. Put that in your calculator. All right, that is 12 radical 2. All right. That is one of the diagonals. All right, we need the other diagonal if we're going to find the area. So the other diagonal is FA. Okay, so here's the other diagonal right here. Okay, so we need to find that diagonal as well. So let's do it. FA. Okay, so forget about O and D. Now we're looking at F and A. Okay, so x minus x, -2 minus 4. And y minus y, that's 1 plus 5 squared. Square root of it all. Put that in your calculator. And that is going to be 6 radical 2. Okay, so if I want to find the area of a kite, all right, the area of a kite is 1/2 diagonal times diagonal, which in this case is going to be 1/2 12 radical 2 times 6 radical 2. Put that in your calculator, see what happens. That's going to be 72. So that is the area of this kite. Okay, finally we need the perimeter of the kite. Well, for the perimeter, we need these 4 lengths. So we're just going to have to do the distance formula 4 times. Okay, so we're going to have to do FO, and then OA, and then AD, and then FD. Okay, we're going to need all 4 distances, because those will be the sides of the kite. Once we get that, we'll just add them all up. Alright, if you find the 4 lengths, these are the distances that you find. Notice I didn't really have to do this 4 times. I know that these consecutive sides of the kite are going to be the same. So once I found that FO was 6 radical 5, I knew that OA was going to be 6 radical 5. So I could have just written that down. Once I found that AD was 6, I knew that FD would also be 6. So I didn't really have to do this 4 times. Anyway, once you get all 4 distances, if I want the perimeter, I'm just going to add those up. It's going to wind up being like terms. So 6 plus 6 is 12. Okay, 6 radical 5 plus 6 radical 5 is 12 radical 5. Okay, I'm still adding the 6's. I could have put all that in my calculator and it should give me the same answer. Anyway, that would be the exact answer without any rounding for the perimeter. But of course I could put this in my calculator and get a decimal real quick. And I'm getting 38.8. Okay, and that would be the decimal form of the perimeter. Alright, and that is it for the homework.